Hello. Today I'm going to participate in AtCoder, and it has been a very huge delay, actually, a big pause, because it's the first time since maybe last year or even 2022 when I last participated in AtCoder. But today is the day. It's time to improve my rating. Let's go. And people are sitting around a round table from 1 to n. Counterclockwise order. Dominant hand and spoons. Okay, we're given a permutation, a string. Yeah, we're given a permutation, a string, which has sometimes question marks. And everyone has taken a spoon at some point. Well, obviously, everybody should take left spoon or everybody should take right spoon, because if you sometimes take left and sometimes take right, then you definitely lose. Yeah? This means so let's sum up two things. The number of ways when everybody takes the right spoon and the number of ways when everyone takes the left spoon. Okay? What then? Yes, so let's look at our permutation. For example, let's assume that we fixed that we always take the right thing. So if this person has both spoons, yeah, then we have to make him right-handed. If this person only has a right spoon, then anything is okay. I think that's it. So we read n. Then we read the permutation. Then we read the string. Then we need to find the answer consisting of p and n and print it. Okay, so string dominant equals LR, and for char C in dominant, let's calculate current answer, and in the end we say that ans is sum of ans and current ans modular m. Yes, so let's go. We need to go through our permutation. so what else I want to do? Int delta equals dom equals L, then m minus 1 n minus 1 or 1. Okay, so let's look at the person. VB has taken of size n, and in the beginning nobody has taken anything. So let's look at the person. For example, current answer is 1 actually. Okay, so we look at the person. So if this person is, we need to check if he has 2 spoons or 1 spoon. To do that, we need to look at delta. Actually, yeah. One, two, three, four. Yeah, we need to look at the person number delta. Int j equals sum I delta n. So if this person has already taken, then it's easy. We can be anything. So if si equals question mark, then current ans is sum of current ans and current ans. But there is another case. If that person has already taken, then if si equals no. If that person has already taken, then it's fine. But if they didn't take, then we have to be right-handed. Yeah, so if si is actually not c, then we lost. Yeah, we say current ans equals 0. And after that, we need to say that taken I is true. That's it. Two, 0, 160. No, it always says 0, 0, 0. Why did it do that? Si is not equal to question mark. Okay, we also need to make this test. 1, 2, 3, LLL. 1, 2, 3, RRR. And 1, 2, 3, L, R, L. Let's submit this. I believe it is okay. And we can solve problem B. We're given a string s of length 2n, accepted, of two types of parentheses. We can perform the following two types of operations in any order, any number of times. Choose a pair of integers and swap two parentheses. Or choose an integer and change one parenthesis. We want to make a correct parenthesis sequence. It can be proved that the goal can always be achieved with a finite number of operations. It's funny that you mentioned that. Okay, so I believe what do I believe? So first of all, let's consider the optimal strategy. And note that if at some point we change this to this and at some point we change this to this, then actually instead of that we could have made a swap. Yes, so first of all, if A is at least 2b, then we just need to make only the second operation. Yeah, but if not, if A so if A is at least 2b, then we can make only changes, and if A is less than b, then we need to make minimum number of changes and then only swaps. Okay? Well, actually, we can reformulate it as follows. Make the minimum number of changes. Yeah? So let the difference between the numbers of opening and closing brackets, parentheses, be d, and let the minimum answer by actions be a. Then the answer in this case is simply a, b, and in this case it is d, b plus a minus d over 2a. So we only need to find these two numbers, and this is trivial to find, so we need to find a. So if I have some bracket sequence, what is the minimum number of operations to turn it into a correct sequence? So let's go one by one. Let's keep track of our balances. So opening, closing, opening, closing, closing, opening, closing, opening, etc. At some moment we see negative balance, less than 0. This means that we have to make this closing bracket opening instead of closing. Then we continue. Yeah, and at some point, so if we do that, in the end, we can end up with positive balance which is greater than 0. What does it mean? And then we can do the same thing from right to left, I think. Can we just do it from right to left? Maybe. Maybe. It seems like we can. But I think I don't know. Well, yes, it's correct solution. Okay, so we read NAB and a string. Yes? And we need to print the answer, which seems to be a long. Okay, so answer is long. What do we do here? So first of all, let's write a function. Let's find the balance. Yeah. So if C equals opening parenthesis plus val, else minus val, and val equals up of val. Yeah, val is up of val, and then we need to find min actions of S simply. And then we can use this formula. So if A is at least to B, we return AB. Return act times B. Else return val times B plus actions minus val divided by 2 multiplied by A. So we need only to find min actions. Okay, so let's go through this string. Let's again keep track of our balance. So if balance equals 0 and SI equals closing parenthesis, then we say plus. Then we say plus act, but SI equals opening. And then this thing. Great, now we go through and the beginning. from n minus 1 to 0, we do quite the same thing. So we again say that bal is 0. If bal is 0 and si equals opening parenthesis, then we make it a closing parenthesis. We make it a closing parenthesis. And plus act. And then the same thing. Okay, and return act. Five, 0, 5 to 1, 5, 3, 8. No, it says something else. It's strange. Why is it incorrect? In the first case, it says that number of actions is 3, and this is fine. But then it does something incredibly stupid. Bal over 2. Yeah. Bal over 2, of course. Yes? I don't understand. Yeah, it seems like this, actually. Yeah? And again over 2. Yes, I think so. 5 to 1, 5 to 8. Accepted. Better than it could be. So we're given several segments, and a sequence of integers is called a good sequence if okay. Find the lexicographically smallest good integer sequence that minimizes this sum. Okay, first of all, let's find just some sequence, not the best one, maybe. How to find some sequence? To find some sequence, we need to choose always Okay, we also want to find the lexicographically smallest sequence. And this means that we want to always choose the smallest possible number. Okay, what we would like to do is to always make the minimum possible jump. Yeah, so in the beginning we are like anywhere in the segment L1 or R1. Anywhere here. Then we have the second segment. And we say that we don't want to make a jump, so we stay here. Then the third one segment, we stay here. And another one and another one. At some point, we have some segment where we can leave, and then we are given the next segment. Yeah, we're given the next segment. This means that actually all this time we wanted to be here, and then we jump here. Ah, okay, again, as I said, we always make the minimum possible thing. But we need minimum lexicographically. We need to minimize it lexicographically. How do we do that? Let's look at all our segments. And when do we actually have any choice? Yeah, when do we have a choice? We have a choice. Hmm. Okay. Well, let's look at our lazy strategy. Lazy strategy says if you are in some point, you should stay in it. Okay. Let's keep trying to follow this strategy. Okay, we're living in some point, and at some point it becomes non-intersecting with us. So if it's here, it's very easy. We just choose this point. The problem starts when we see that the segment is actually to the left of us. Okay, if the segment is to the left of us, then at some point we will move only to the left. We will only move to the left. Okay, I see. Let's look at our greedy strategy. Greedy strategy does the minimum possible number of actions. So our graph looks like this. So we live somewhere, then we go up, then we go down, then we go up, then we go down, then we go up, etc. So when we go up, it's actually okay because we could never go up less than we did. However, when we go down, it is possible to go down a bit more. Yeah, we could go down earlier than we did. Yeah, so how to fix this? How do we fix this? Actually, I think that we need to choose the segments of going down. Yeah, so let's choose the local maxima. That is so when I say local maximum, I mean let's consider the point after which we make 0 or more horizontal steps, and then the next non-horizontal step is going down. Then something happens, then we get to local minimum. It is the point after which we do not make the move down. And then I claim that we just need to take this sequence and reverse the algorithm. So we need to go through it backwards. We need to go through it backwards. And that's it, actually. Yeah, just need to go backwards through all such segments. Okay, let's go. So we need to read N and VPII. Okay, first things first. Let's find the first moment of when the segments do not intersect. Yes, so let's take int L equals -1, R equals 2e9. So if segments is including, yeah. So if the vi is less than L or vi int start, I also need to choose a starting point. So if vi is less than L, this means that, oh, not vi, but vi.y is less than L, then I need to choose as a starting point L. Else, if vi.y.x is greater than R, then I have to start equals R and also break. And then I need to say that L is minimum of L and vi.x, and R is maximum. Actually, L is maximum, and R is minimum of R and vi.y. And in the end, if start equals -1, then start equals L. Okay, now I need to construct the answer. Answer 0 is start. So the greedy algorithm is straightforward. So if ans I plus 1, ans I, if vi.x is greater than ans I minus 1, then ans I equals vi.x. Else if vi.y is less than ans I minus 1, then we have to jump to vi.y. Else we jump to the previous point. Okay, this is already an optimal answer, however, it is not lexicographically smaller. To make it lexicographically smaller, we need to consider all what do we need to consider? Let's go through from beginning to ending. Yeah, so if we have just jumped up, yeah, that is ans I plus 1. So if ans I plus 1 is greater than ans I, is greater or equal actually than ans plus y, ans I, then we were going up, and when we are going up, we are already doing it optimally. So we do not need to do anything. So now let's assume that ans I plus 1 is less than ans I. This means that this is actually this place. So actually we're going down here. Sorry. Yeah, we're going down here. Okay, since we're going down, we need to minimize something. Okay, we need to reduce our number. We need to say that ans I is minimum of what? Of ans I and something. Actually, we can choose it as a maximum. It should be at least ans I plus 1. And vi.y. vi.x. Maybe that's it. Let's check. Let's try and check it. Eight eight 8845 20 20 20 and a lot of numbers. Actually a lot of numbers. So let's look at them. Okay, let's try and submit it because it seems correct. Although it might be incorrect. Compilation error. Are you kidding me? You cannot read VPII? It's really strange. It's the first time I see this problem. Very weird. Okay, LIS on tree. There is a tree. The ith edge connects UI and VI bidirectionally. For a permutation P, we define f of P as follows. For each vertex, we take the simple path from 1 to I and take the longest increasing subsequence of P. So 1 is a root. We take all paths from the root to a vertex and take the longest increasing subsequence. And we sum up their lengths, and it is f of P. The question is there a permutation with such f of P? Okay, we need to apply a discrete continuity. So what I think is that if L is the minimum answer and R is the maximum answer, then all answers between L and R are also possible. What is the minimum possible answer? Minimum possible answer is when everything is increasing. And always the answer is the length of path. And the minimum possible answer is when everything is decreasing. Okay. Okay, so again, we have a tree. If we always make increasing paths, then the answer is easy to find. It is like sum of all possible of all hi plus 1s. Yeah, so sum of hi plus n is the answer. It is maximum possible answer. So minimum possible answer is just n. And we can make any number between that. Let's try and do that. So okay, first of all, let's subtract n and assume that the length of the longest increased subsequence is decreased by 1. So we can make anything from 0 to sum of hi's. Let's prove that. So assume that we have a tree. And what? We want to make something from 0 to sum of hi's in this tree. How do we do that? Okay, this is quite straightforward. So we have sum of hi's. And actually sum of hi's. So we have some root and we have some children. Yeah, we have a root and we have some children. Sum of hi's is a1 plus etc plus an plus a k. So there are two cases. So if ai, so when we reduce this problem to this one, actually instead of ai, it becomes ai minus size of subtree of ai, of vi. So we need to ask a question. So do we make this subtree smaller or greater than r? Because if we make it greater than r, then we can add this SOS of AI. And if we make it smaller than r, then we don't make plus SOS. Assume that our answer is less than SOS. Is it true that we can make the answer Yes, I see. It is an easy problem. It is just a DFS problem. Okay, all input values are integers. N, K, then we read a tree. So if ans is empty, return, not return, we print no. Else we print yes. And we print the permutation. Okay, find answer. Find answer. And we need to make some like parents, children, etc. Okay, this size +1, and we immediately subtract subtract n. Then we need to make a DFS, which calculates... Yeah, we need to make a DFS which calculates the sum in every subtree. The sum of heights in every subtree. DFS in 0, G, and V not visited. What I want here. I want to check sum and subtree. So VLS of size n. Size of subtree, sum of heights in subtree. Yeah, that is fine. So let's go. First I will say that now this vertex is visited. But then we go through all GV. So if NV2, so what do? We need to run DFS of 2 G and V SSH. We also need to say that SV is 1. And here we say that SV plus equals S2. But not only that, we also change SH of V. It is SH of 2 plus 1 for each vertex there. So plus S of 2. That's it. Okay, let's say immediately that if k is less than 0, return nothing. Here we can say if k is greater than sh0, we also return nothing. Otherwise, let's make val ans of size n and return ans. And before returning, vi ans, we need to run a recursive DFS. DFS is always recursive. DFS perm. So we have again 0 g. Let's again assign n true. So nv shk sshk ans. And also L and R. L and R, which are 0 and n. It's quite huge, but we have to do it. So what do we do inside our DFS? So we have some k. First of all, we need to say that k is sum of a1 plus etc. plus an, for where a1 etc. an are children. Okay, and then if this number ai is less than SOS, we make our number bigger. Otherwise, we make it smaller. Okay, I see what we need to do. Well, it's not hard. We can do it step by step. So again, NVV is false. S3 we don't change. Actually, we only have consts here. Also, I'll say that in the end, ans v becomes L. Okay, so what do we do here? We need to put here a number which is as big as possible. So it is a minimum of current k and sh of 2 plus s of 2. Then we say that k minus equals ai. Then there are cases. So if ai is at least s2, then this thing will be greater than our root. So we need to take the biggest, give it the biggest possible numbers. So we say DFS perm of 2 GNV SSH not K, yeah, K, AI minus S2 ans R minus S2 R and R minus equals S2. Else we make a DFS perm, but for the smallest possible numbers. So from L to L plus S2 and L plus equals S2. I think that's it. Yeah, I think that's it. First of all, let's take this sample, I think. 1, 2, 2, 3, 2, 4, 4, 5. 1, 2, 2, 3, 2, 4, 4, 5. And they say that they want to put theater 1 for 5. Let's count the longest increasing sequences. So it is 1, here it's 1, here it's 1, here it's 2, here it's 3. In total it is 8. And it should be 8. Okay, let's look at our answer. We didn't print. Ah, we need to add 1, I think. Okay, my answer is 5, 4, 1, 3, 2. I say 5, 4, 1, 3, 2. Let's see. So it is 1, 1, 1, 2, 2. No, it is always decreasing. No, it's always decreasing. Ah, I need to write here just AI. Five, still 5, 1. Ah, 5, 1, 4, 3, 4, 3, 2. Okay, so it is, the answer is 1, 1, 2, 2, 2. Yes, it is 8. It is equal to 8. Then it says no, and then it says yes. So I think we need to draw this example and submit. and get accepted. So that 3 was 3-1. Three 8, 7-1, 7-5, 3-2. Six 5 for 7. And my answer is 1762, 4538. Okay, let's calculate the answers. So here answer is 1. Here answer is 2, and here answer is 3 and 3. Here the answer is 2, here the answer is also 2. Here the answer is 3, and here the answer is 4. So the answer is 1 plus 2 plus 3 plus 3 plus 2 plus 2 plus 3 plus 4. Okay, this is 9, this is 4, and this is 7. So this is 16 plus 4, which is 20. And I needed to get 20. So let's submit this. Okay, accepted. Now we're fine. Okay, we need to solve problem E. Okay. Okay. Interesting problem, actually. I have absolutely no idea how to solve it, but this is fine. It should be so. Okay, what we would like to do is to do it by induction. And to do it by induction, we would like to decompose the problem into smaller sets of cubes. Okay? For example, when you're asked to do it with at most n cubes, it's easy that you can just take the diagonal. But it gets trickier when the answer is greater than, when you are asked to do something greater than n. For example, how do you usually do n plus 1? Yeah, so we would like to do something by induction. Maybe we just need to find a way to add one more cube. So we have already done something and we need to add one cube. Okay, let's try and do it. Okay, I think, for example, that we can replace, if we have 1, 1, 1, for example, and 2, 2, 2, we can replace them with 1, 2, with what? Actually, with 4 cubes. We can replace them with actually I see some. Let me think what I see. Actually, so let's look at oh, sorry, at all elements, and let's decompose all of them into some cycles. Yeah, so assume that we can decompose everything in cycles. then actually, so if we have a cycle 1, A2, A1, A2, etc., AK, we can make the following pieces, the following figures: A1, A2, A3, A2, A3, A4, etc., A something, something, something. And we won't see any of these. Actually, we want to decompose directed graph into cycles. Yeah, so we want to decompose directed graph into cycles. So there is a special tricky case when n equals 2, when it is not possible. Okay, because this is not good. However, in all other cases, I think it should be. It's not possible when you have an even n. Yeah, but, yeah, when you have a cycle is always, it always has even degree. In that sense, you just want an Eulerian cycle, and you cannot make it when you have n equals 2. Well, you can. Yeah, you can, because between each pair of vertices we have 2 edges. So we want to make an Eulerian cycle, and the only restriction is that we don't want to go to vertex and immediately out of it. So is there a way to do it? Maybe we can do it by induction. I don't know. So 1, 2, 3. 3, 2, 1. And it's fine. Okay, I still have a little time. Ah, no, I wasn't correct. I cannot do it. So if I do like this, see the pair A1, A3, it is here, but it is not here. No, I cannot divide it into cycles. I need to divide it into triangles. So it should be exactly triangles. Well, it shouldn't be hard. Yeah? Why it shouldn't be hard? Why do I think that it shouldn't be hard? It shouldn't be hard because I really don't know why it shouldn't be hard. But it shouldn't be hard. Yeah, I just need to divide all vertices into triangles. Yeah, for example, let's all edges into triangles. For example, let's make by induction we take n, and we need to take all triangles like this. And for example, we can perform this. Also, each edge should be traversed one time in one direction and one time in the other direction. So if you do like this, we simply eliminated a Hamiltonian cycle. So now the question is, can we divide a graph without a Hamiltonian cycle? I don't know. Let's try and do it at random. I think it might be possible. So what do I do? What do I do? Okay, so what do I want to do? I want to divide everything into triangles. Okay, so actually we have an exception, yeah? So n equals 1 and n equals 2 are exceptions. Okay, so if n, first of all, if k is at most n, then it is easy. We say that ans I equals I, ans I equals I, and return ans. Also, if n equals actually, let's do it like this. I want to say that I want k divisible by 3. So if k, not if k, just what do I want? I want to say that I want to take k minus n and go up to the nearest number which is divisible by 3. Okay, so if k is at int diagonal. So if k is at most n, then diagonal is k, else diagonal is what? So I need to take as many numbers as possible, such that after it, no, diag, k, yeah. After that, so we need to take k minus n, yeah, and take the smallest number which is divisible by 3, which is at least this number. It can be done like this. So now this number is divisible by 3, and this is the new k. And this is diag. After that, we say we want VVI ans equals find non-diag ans of n and k minus diag. Then we do this, and we return ans. Okay, now we have this task where we are not allowed to take I. Okay, in this task, if n equals 2, okay, if k equals 0, we can return nothing. If n equals 2, so we know that k is divisible by 3, so definitely k is just 3. And we can return, actually, not even if n equals 2, but if k equals 3, we can return, no, we can, if n equals 2, we can 1 to 2 2, 1, 2, 2, 2, 1. Okay, actually, one less. Okay. Okay, so we have n at least 4 and n at least 3. So since we have n at least 3, what can we possibly do? Okay, actually, if n is divisible by 3, it's easy. N is divisible by 3, then easy. Why is it easy? Because we can just take residues modulo n, and we can take like a, b, and 1 minus a minus b. And it's not possible. It's possible to have. We can't have equal numbers here. No, it's not easy. Maybe we could have a plus b over 2. But then we want that b plus a plus b over 2 is again a. And this is not correct. I remember. I wanted to try just to do it. Well, still, it's not always possible, because the number of edges might be not divisible by 3. Yeah? The number of edges might be not divisible by 3. That's why sometimes I have to... Oh my god. Because the number of edges sometimes is not divisible by 3. That's why sometimes I have to add, so instead of like 1, 1, 1 and 2, 2, 2, I have to use 1, 1, 1, 1, 2, 2, 2, 1, 2, and 2, 2, 1. I just have to. Is it true that n times n minus 1 is always 0 or 2 modulo 3? Yes, it's true. Okay, so if n is not divisible by... If n is 2 modulo 3, so... n you know what? I understand. I see sometimes we have a tricky case. Okay, so if k minus diag is at most n times n minus 1, then I can do it. However, sometimes it is not the case. And in this case, I need to do this. I need to do this. And I need to do this. Oh my god. Okay, to do. Not much time. Not much time. Okay, we're going to try to divide everything, all our entire graph into triangles. Maybe we can do it greedily, for example. Okay. So if k is greater than 0, then, for example, let's throw 0. Okay, what do we do here? We need to take VVB used. Can. Then I need to find if PL, if can IJ and can JI, and then PL equals I, PR equals J, break, okay, if what? If PL equals I, then I say plus plus T, else this. And the same here actually. After push back this. Okay. In the end we need to add some more things. We need to add PL, PR, PR. And return it. Okay, there's an exception because n equals 3 and it was unable to divide 3 vertices into what? What was k initially? K was 4 and diag was what? Ah, k minus equals 3. Okay. Why minus ones? I don't have time to have minus ones. Okay, it failed when n equals 4. Hmm. How do we find a lot of triangles in a graph? Hmm. Hmm. Omnic solved this problem in 8 minutes. Not bad. Not bad. Actually, I didn't notice that k equals n square is the solution. It's not hard. It's not hard, but I was solving more difficult problem than it was required to. Oh my god. Are there people that I know? It's the first time. What? It's the first time Maxim participates in a round since 2021? Are you kidding? For instance, I last participated in 2022 and it wasn't good. Gas. Oh, and I actually defeated Belik. Belik is Ivan Bachkov. And I destroyed him. Yeah, problem it wasn't hard. It's not really a shame that I didn't solve it. However, it's not good that I didn't solve it. Well, okay. Okay, thank you for watching.